Hello everyone, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all exams. So in this concept capsule series, now today we are going to discuss storage classes in C. So let's start because this is very important topic and we should know this. So before starting, let me introduce myself. My name is Anshul Sharma. I have 2+ years of experience. In GATE 2020, I have secured All India Rank 294, cleared ISRO and ELET exams, mentored more than 1,000 students, and these are my area of expertise. So also, if you want to connect with me, you can join this Telegram group. This is my Telegram group. So you can just search this Telegram group through this link and you can connect with me. You will be getting PDF of all my YouTube classes, doubt clearances, as well as if you need any guidance, then also you are most welcome. So let's start the concept of storage classes in C. So basically, storage classes in C that we use to determine the lifetime, the visibility, that means we can say the scope, memory location, and the initial, which is the default value of a variable. So we use these storage classes so that we can get to know these four things of a variable that we are going to use in our program. That is lifetime, scope, memory location, and initial value. And there are four types of storage classes in C we have. The first one is automatic, second is external, third one is static, and fourth one is register. Now let's see one by one. So here in this table, I have summarized the storage place, the default value, the scope, and the lifetime for all these storage classes, and the keyword that we are going to use for every storage class. So for automatic, we use a keyword that is auto, right? And it is, by default, even if you are not using, still it is going to be auto only. We are going to see many examples also. So in a storage place, so basically whenever we are declaring any variable as auto, so that will be getting the space in RAM, that is your main memory, where the program execution happens, right? And the default value, suppose if you are not initializing that variable, suppose you are writing auto int x semicolon, that means you are not initializing the variable, right? In that case, it will be having some garbage value. Garbage value means it can be anything, right? Any random thing it will be having in it, right? And if I talk about the scope, so scope will always be local for this auto variable, right? Local means that means suppose you are initializing or suppose you are declaring that variable inside a function. So it is going to have its scope just within that function or that block. Okay. And the lifetime is going to be within the function. For example, you are initializing int within main function or any f1 function. Suppose you are writing auto int x semicolon. So in that case, you can just access that variable just within that function or that block only. Okay. Once the function, the activation record for the function will get popped off, this variable will no longer be existing in the memory. Clear? Then we have this extern. So basically, for external storage class, we have this keyword that is extern. We have to use it, right? So it is going to be this keyword first, then the data type of the variable and that variable name. Okay. Again, the storage class, I mean, the storage place will be your main memory, the RAM, right? And the default value for extern will be 0. So it is always going to have a 0 as the default value if we are not initializing it. And we will see many examples also. The scope will be global. So basically, we use this extern storage class for the variable so that suppose we are having for a single program, we are having multiple modules, let's say. So if I want to use that particular variable in other modules of the program, then I have to declare that variable as extern variable. And there is one more benefit of the external variable that we don't have to allocate the space again and again, right? Once we allocate the space to the external variable, in that case, we can use that space in anywhere in any other module of the program. Clear? That is the main purpose of using external. And what about the lifetime? So till the end of the main program may be declared anywhere in the program. So we can declare it anywhere in the program, but this extern, let's say if I'm writing extern int x, so that should be outside the main function. Then we can declare and define it anywhere in any module of the program. And we will see two examples also. Then we have a static storage class. So in case of static storage class, the storage place will be again your main memory, right? And the default value is going to be 0. The scope is local, and the lifetime is going to be till the end of the main program. Once your program exits, in that case, the space for that static variable will no longer will be existing in the memory. Okay, and it retains value between multiple function calls. So there is one important functionality of static variable. Let's say if I'm writing static int I, and if I'm suppose initializing it with 10, right? In that case, if let's say multiple functions are accessing that static variable, so for static variable, it is going to be initialized only once. So once we are initializing it with 10, then in that case, we can just increment or decrement the value, right? We cannot initialize it again. So if I want the value of a variable to be initialized once, then in that case we use this static storage class. Okay, and then the last one we have is a register. So the keyword is register, and the storage place. So basically we use this register storage class when we want fast execution. So we can write register int I and then some value if we want to initialize it, right? So what happens is, why is it so fast? Because the storage that you are going to get will be in the CPU, not in the main memory. And basically it is going to be like a general purpose register. Okay, so in general purpose register, you know, that is already residing in the CPUs, right? And we can quickly access that and we can perform some operations. So it saves some time as compared to saving the variable in the main memory. Okay, so storage place will be basically you can say CPU here, CPU registers. Default value will be a garbage value. It can have any value if you are not initializing it. And scope will be local, that means, and lifetime will be within the function or the block, we can say. Two examples, we are going to understand every storage class now. So first of all, let's talk about automatic. So in case of automatic, let's say here I'm writing int a, right? So by default, this is auto. By default, this is auto variable, clear? Or I can also write like this, auto int a. Similarly, this is also auto variable, this is also auto variable, right? And now we are printing. We have not initialized them, we are just printing them. So what is happening? As we know that auto storage class will be having garbage value if you are not initializing them. So in that case, variable will be giving us some garbage value. It's not like garbage will be print out, but we are going to get something randomly, right? So that is the garbage value. So it is not mandatory that we have to use auto keyword here, because it is by default. By default, any variable is your auto variable. Clear? This is example one. Let's see one more example. Now here, if you see, we have the int main function. We are initializing the value of a, that is 10, and then we are printing it. So this is a pre-increment. So we are printing. So definitely a value, if we have a as 10, it will be incremented by 11, and then we are going to print it. So a will be printed as 11. Now, if you carefully see, after that, we are having braces here, right? We are creating a block here. And then again, we are initializing int a is equal to 20. Now, that means if I'm going to access within this block, if I'm going to access this a variable, it will be taking the local variable. That is, here it will be considering a is equal to 20, not a is equal to 10, because that is outside its scope. So it's always consider the nearest variable value. Okay. So here it is a for loop, I is equal to 0, I less than 3, I plus plus. That means it is going to run three times, 0, 1, 2. Three times it will be printing a value. So a is 20, so it will be printing three times 20, 20, and 20. So this scope is gone. And now outside this scope, again I'm printing the value of a. So for this printf statement, the nearest would be what? This one, that is a is equal to 10. So we have updated basically 11. So we are going to print 11 now, not 20, because 20, the scope of this int a is equal to 20 is over after this braces. Okay, so always it is going to have local scope. That means within that block or within that function. Is it clear? Now, let's talk about static. So in case of static, let's see this example. Here we have static char c, static int I, static float f, static char s, that is a array, right? That is storing 100 characters. And here void main, right? And we have a printf statement which we are printing the value of all these static variables. We are printing this c, I, and f basically. So here, if you carefully see, here we are going to, here it should be s also, right? So here we are printing these values, right? And we have not initialized it. And we know this that in case of static storage class, right? In case of static variable, by default, the value will be 0. So as you can see, for int, for char, it is going to print 0. For int, it is going to print 0. For float, also it is going to print 0 like this. Clear? Let's see another example for static. So here we have this void main function, int I, right? And then we have a for loop, I is equal to 0, I less than 3, I plus plus. That means it is going to run 3 times, 0, 1, 2, 3 times. And we are calling this sum function 3 times. So let's say first, when we call this function for the first time, what will happen? Sum is defined here, right? Now we have a static int a. So we have a static int a 10, and we have initialized this to 10. Then we have a b variable which is also static, and we have initialized to 24. Right. And now we are printing the value of A and B. So obviously 10 and 24 will be printed, correct? Now we are incrementing the value of A first. So it is 11 now. We are incrementing the value of B then. So it is going to be 25. Fine. Now again, we are going to call this sum function. So what will happen? This initialization will not happen again. That is the speciality of static. Initialization happens only once. So after that, when we call the sum function for the second time, we are going to execute this printf statement, and it is going to print the value which is 11 and 25. And then again it is going to increment a and then b. So we are going to get 12 here and 26 here. Again, for the third time, for the last time, we are going to call the sum function. So it will execute this printf statement first. It is not going to initialize it again, right? A and b will be printed, and we are going to get 12 and 26 because 12 and 26 is here, right? And then again we are going to increment it by 13 and this by 27, and this for loop will stop now because 3 times only it is going to run. So this is going to be the output. So I hope it is clear how this static storage class works, right? Now let's talk about a register storage class. So here in this, as you can see, we have this int main function, and we are having this register int a variable, and we are trying to print the value of a. We know this in case of register, if we are not initializing, the default value will be 0. So the output that we are going to get is 0. Now let's see the second example. So here we have int main function, register int a is equal to 0. So we are initializing the value of a as 0. But what we are printing? We are trying to print the address of a. Now keep this in mind in case of register. As we know, if we are initializing this as register, right? If you are declaring this variable as register, in that case, the register will get the space in the CPU, not in the main memory, right? So you cannot use a dereference operator with a register variable. That means you cannot get the address of a register variable. You can get address of any variable which is going to reside in the main memory, not in the CPU, not in the CPU register, right? So that is why it is going to give you error. It is going to give you error. It will throw error. That means you are accessing, you are trying to access the address of register variable, which is not allowed. Clear? So we cannot use dereference operator with this a variable here. Clear? This is very important. And also just understand this point that whenever we are writing register int a is equal to 0, basically your compiler is going to request the CPU to allocate this variable into register. Okay. So now it's up to CPU if it is having those many registers to allocate the space, right? pre-register, then in that case it is going to approve that request, otherwise no. Otherwise your variable still will be getting the memory in the storage in the main memory, not in the CPU. So it's all up to the CPU whether it is going to approve it or not based on the space available for register. Clear? And one more thing, we can store address of any variable in the register. That is allowed, but we cannot get the address of the register variable. Okay, I hope it is clear. Now we have the last one, that is external. This is very important, and there are very important points that is written here. We need to understand each point carefully. The external storage class is used to tell the compiler that the variable defined as extern is declared with an external linkage elsewhere in the program. That means when you are writing extern int a semicolon, so that statement gives the or tells the idea, tells the compiler basically that you are declaring this variable somewhere else in the program where you want to use it. Clear? The variables declared as extern are not allocated any memory. So once we write extern int a, we are not allocating the memory. Memory will be allocated when we are going to declare and intended to specify that variable is declared elsewhere in the program. So basically, when we are writing extern int a, it is just for telling the compiler that somewhere else in the program we are going to declare it, we are going to define it, and we are going to initialize it. Okay, and then the memory will be allocated, not just by writing extern int a. Memory will not be allocated. The third point is the default initial value of external integral type is 0. So basically, when you are having the default value for extern variable would be 0 here. Okay, it is not going to have garbage value, it is going to have 0. We can only initialize the extern variable globally. So whenever you want to initialize the extern variable, we have to do it globally. We cannot initialize the extern variable within any block or any method. This is also very important, and we will see through examples. An external variable can be declared many times but can be initialized at only once. So let's say you are having 4 modules of a program, right? And you want to use this external variable. So in all the modules. So what you are going to do is in all the modules you are going to declare it. Let's say you are somewhere you are writing external int a semicolon. Now this int a you can declare anywhere you want to use that variable. Okay, but initialization that will be done only once. Clear? The last point is if a variable is declared as external, that means using extern, then compiler searches for that variable to be initialized somewhere in the program. So it is going to search in the entire program where it is initialized. So which may be extern or static. If it is not, then compiler will show an error. If it is not initialized, it will throw an error. Now let's see some examples for this. Here we have int main function. We are writing extern int a. So now if I'm trying to print this, so as you can see, we are trying to print the value of a, right? But the point is we are having this extern inside the main and we are not using that anywhere else in the program. So that is why we are getting the error. That is undefined reference to a. Clear? When you are writing extern int a, you have to use somewhere else outside this. Then only you can access that. So let's see this next example. So here you have int main, right? And you are writing extern int a. So before now here, if you see, we are having int a, we are declaring int a. This is not, this is just to tell the compiler that we are creating one external variable, but you have to declare it somewhere else. So here we are declaring int a for this given program. Now, variable a is defined globally. Yes, the memory will not be allocated to a. So here it is if you are printing the value of a. So we have declared it, but we have not initialized the value of a. So in this case, it is going to print the default value. It is going to print the default value, which is 0. So this extern int a statement, it is just indicates that we are going to define a globally and memory will not be allocated. Memory will be allocated when we are going to initialize that. Okay, clear? Otherwise, it will just print the default value when we are writing this int a here and we are printing the value of it. Let's see the third example. Here we have int a, fine. Int main here. Extern int a is equal to 0. Now what is going to happen here? So if you carefully see, this will show a compiler error since we cannot use extern and initialize at same time. Now, based on the point that we discussed here, carefully see. So here we cannot do it simultaneously. We cannot declare and initialize simultaneously. That is not allowed. Clear? That is not allowed. So here if you see this example, this third example, we are declaring extern int a and at the same time we are initializing it. So this is not allowed. You have to initialize somewhere else when you are going to access that variable. Okay. So when if you are printing now, you will be getting compile time error. Both extern declaration and initialization cannot happen simultaneously. Let's see this example 4. You have int main here, right? And you are writing extern int a. Okay. And you want to print the value of a, but you are defining int a is equal to 20 here. So compiler, what it will do, it will search the entire program where a is defined. So a is defined here and it is initialized also. So yes, it is going to print 20 as the output. Clear? That means the conclusion of this extern storage class is if you are writing extern int a in your main function, then you have to declare it somewhere else in the program and you have to initialize it to access that. So we are declaring somewhere else outside main, right? And we are initializing as well so that we can get the value 20. And you can do it anywhere else also. That means in all other modules of the program also, you can write int a is equal to something. You can access that. Fine. Now, carefully see this. We have extern int a here. Fine. Now we can write extern anywhere. Int a is equal to 10. That is fine. That means we have uh, declared the variable a and we have initialized also. Now we have int main function. We want to print the value of a, and here also we have int a is equal to 20. That is not allowed. Why it is not allowed? Because in the same module you cannot assign, you cannot initialize more than once, right? That means your external variable cannot be initialized more than once. It can be initialized only once. And here we are initializing 2 times, 10 and 20. That's why you will be getting compile time error. So that's it for the storage classes. We have covered all four storage classes along with the examples. So, and if you want to connect with me, you can join this Telegram group to get the PDF and the guidance. So thank you all of you for joining this, and do subscribe to BYJU'S Exam Prep YouTube channel so that you don't miss any videos, any concept capsules, and the technical classes that are going on currently on our YouTube channel. So like the session, share with your friends, and press the bell icon and keep learning, keep improving. Thank you.